Hi there, I'm here again and get the LLM testing series continued for the sake of exploring testing tools for testing LLMs. First, let's dive into the uh, last week's live session and the video which came out this Wednesday. Let's jump right in the topic, and afterwards we will explore what testing tools we should use or will use, or I don't know, we will see. So now let's start it. I will share my screen. Hopefully it works. Yes, it's working. So okay, this VS Code prepared, but I also prepared this Google Sheet. Basically, that's the output of last week's test. The output was a CSV file I imported with Google Sheets. And finally, I've selected three large language models, which is the Phi-3, the Tiny Llama, and the Stable LM2. And these are the test prompts, the 10 test prompts I use for every model, and here is the responses. And finally, I personally evaluated if it's passed or failed and made some notes out of it and some summarization with this sheet, and just quickly go through all these three models are fine-tuned. These are instruct models, so it's fine-tuned to respond and even have a chat with them, made them available to do that. It was a classification. As far as I recall, all three of the models, so Phi-3, Tiny Llama, and Stable LM also passed this test. It was not a hard task even with these small versions of these relatively small large language models. The second prompt was to select the organization and the location from the statement, which was the United Nations and New York City. Phi-3, which was the largest model, it's clearly passed this. The first fail occurred with the Tiny Llama, so the response was just clearly that the selected text. That was the response. Of course, it's not a good. Did not select the needed information, and Stable LM just made it happen. It was the third prompt was the explanation. What is the greenhouse effect? All three language models was quite good explaining that. Describing the life, it's just describing a day in the life of a time traveler who visits ancient Rome. It's supposed to test if this language model, how creative it is, how should it keep context during a relatively long. So this is the length of the text and how factually correct the whole stuff. I think that's the first which every model just failed, because in this case that if of course it's kept the context, factual was correct, but there was a lot of misspellings. It's misspelling spellings. Okay, maybe I'm not even better than a large language model. Okay, the fourth one are the phrases. She enjoys hike in the mountains, or she loves trekking in the hills. Similarly meaning the answer, of course, it is yes. The response was quite good with Phi-3, but Tiny Llama failed again, and also Stable LM passed the test. Correct the grammar sentence. She don't like the movie. Of course, the answer is she doesn't like the movie. All three language models passed this. Passed this test. What is the result of 45 multiplied by 9? It was the most surprising thing that the Phi-3 just really failed, and it tried some kind of, I don't know which explanation it is, but it's hallucinated a lot. With that, Tiny Llama came up with some kind of, I don't know why, this result. It's not even close, and yes, That's another interesting approach. Not even close. What is the result of the arithmetic expression of this? Which the correct answer is 12. As far as I can recall, it's not really a complicated mathematical expression, but of course it's a bit more complex than the previous one. Only 5-3 passed this test, and the explanation was pretty clear and thorough. It hallucinated a lot, and yes, the stable LLM was close with 11, but it is not the correct answer. And the last two, yeah, so this one, the logical reasoning or causal thinking, that if all cats are animals and some animals are not dogs, can we conclude that some cats are not dogs? And yes, the correct answer, we can conclude. As far as I recall, yeah, only 5-3 can conclude or could conclude that. The last one is a bit tricky question. What is the capital of Paris? There is no such thing as capital of Paris, and 5-3 just quite good, was quite good evading this trap. So the revised, it suggested the revised question, what's the capital of France? Maybe that was I would like to ask rather than this one. It was, and it supposes that it could be an issue of the prompter in the capital city of France, and it really verbose response on that. And all the other language models failed with this. Yes, that was the answer. Capital of France, and by extension score, the city of Paris is located in the district. Yeah, so it's not the answer, because I did not ask that what is the capital of Paris. It was a capital that was what I asked. Stable LM as well. It hallucinated a lot. Anyway, the result summary is just this little table, and I just copied the sizes of the parameter amount training these models are having, and just really reflect the performance of the models. So yeah, that was the simple time question prompting for testing the large language models. But yeah, that's for the last week session. But this week's session, I would like to start to explore what tools we have, because of course it's a completely valid way of testing large language models, the prompting and checking the response of the different prompts. Of course, these were not the brightest prompts for testing large language models, but they were okay. I guess I came up with those. So there was that we can test large language models with this kind of methodology. But what if you would like to run a regression test, for example? If there's a language model, and let's assume the situation that we are working to a team or in a project which develops a large language model, and we would like to execute regression tests after different epochs of fine-tuning or training the model. And we would like to know that if the model gets better or worse. We, of course, came up with, I don't know, 60, 100 questions, but evaluating these questions and these answers mainly, it's quite a thorough work manually, and it feels like a bit of waste of resource. So there should be a smarter way, and there is a smarter way according to my research, which using some statistical measurements, and based on those statistical measurements and different kind of methods, we can see how the large language model performs. I searched, but I haven't concluded anything yet. And let's jump right into this natural language toolkit. It was developed in the beginning of the 2000s, in the University of Pennsylvania, I think, but it is mainly for experimenting, for research, and for prototyping language model processing, natural language processing. But it's really widely used, developing large language models or even testing, evaluating, analyzing natural language processing mainly. It is really broad documentation exists in the very same page. What would be the best solution for this for this challenge? To use some really surprising tool, ChatGPT, um, to guide us how to use this natural language toolkit, figuring out how good is the response of three locally deployed large language models, or maybe not three, just one. But let's see how to use it. Let's jump right into it. Okay, but yeah, the real there are metrics, but what we can conclude. Okay, here we are. We can conclude, for example, the lexical diversity, grammatic error rate. Nice one. Example implementation. You can implement a combination of these metrics in Python function using related libraries depending on what aspects of the large language model performance you want to focus on. For instance, the function evaluating syntactic complexity, lexical diversity, and readability might look like this. Evaluate. Basically, it creates the function in Python. We will try it. I already created a virtual environment. Yes, of course it's not understanding because I have not installed it, so I'm already in the virtual environment and instead NLTK and text that the libraries are installed and all the problems just disappeared. So, what is the response? Nothing. No error, no nothing. I don't know. That maybe I should see some instructions first. Installing the NLTK. Maybe I should install NLTK data. Does it even work some way? Okay. I think I really made a rookie error for not saving the Python file. It really searches for the NLTK data. Resource punk not found. Please use the NLTK downloader to obtain the resource. So I will start Python interpreter. NLTK download. Nice. It downloads all. Okay, it's finished. Let's start VS Code. Execute the Python file. Actual output. Nice. Okay, there's numbers and texts and things. We have lexical diversity. Interpretation. A higher score indicates richer vocabulary and better usage of language. A lower score may suggest redundancy. What is that stop word ratio? My understand is that the less the stop word ratio is, the more meaningful the answer or the response. POS, what was the POS? Counts parts of speech. What is the NNRBDTJJ? I will ask. Aha, okay, there's some kind of words. Let's see if it's correct. quickly, very fast. What was the DT? That was the determiners. Big brown. Okay, yeah, there's some natural language processing lingo. Okay, it seems like it's working. Okay, it's working properly. Yeah, I would like to remind ChatGPT that what was the listed metrics, and I would like to have ChatGPT to suggest me how to include all these into this evaluate LLM response function. I can't really wait that if it's ensure the prerequisite resources are downloaded, they are downloaded, and it even gets me explanation to the metrics. Let's copy that. Let's execute. Okay, I would like to remove those because these are downloaded. Eventually it did not run into any issue. Already up to date. And these are all the metrics. Wow. Have these until the Flash Kincaid grade. Let's understand education grade level required to understand the text. So it's not that high. Flash reading ease score. That's the Flash reading ease and the Flash Kincaid grade. That's two different things. Flash Kincaid grade level. Okay, that's a Flash reading ease scores. Okay, now I understand. 0 to 100, and it's 106. Higher is easier. Okay, that's easier than easy. Sentiment polarity. The average sentiment, how complex sentences are by counting the average number of words. That's okay. Fluency and coherence, that's a sentiment polarity. Okay, indicates the positivity or negativity of the text from the scale of -1 to +1. It's a bit positive-ish, but it's neutral. Sentiment subjectivity measures how subjective or objective the text is. I think it would mean that it's objective more, because closer to 0 would mean subjective. Content word ratio, information density. The ratio is meaningful words, the total word count. Okay, transition word ratio. What is the transition word? The proportion of transition words in the text indicating how well ideas are connected. Yeah, I think that it's some however or in concluding or that kind of words. Okay, repetition rate is the error. Analyze its frequency of the most repeated word, indicating redundancy. I think the higher value means that it's a worse result. And keyword relevance, the proportion of text that matches a given set of keywords indicating relevance to the prompt. These are nice metrics. I think the next step would be to get that integrated to our deployed large language models and execute these tests, and let's see how the metrics will form in each and every test and evaluate afterwards. Oh my, it will be a long session. Let's work with that directory, because in that directory I have the olamas crash test dummy.py. Copy the file here. All the thing I need to do is to include evaluate this LLM NLTK sandbox for this file. Yeah, first of all, let's select the first one, and I will let you comment these. I want to have that. Why can't I have that? Okay, because of the hyphen, it does not work. Okay, let's rename it. Ha. Okay, that was the issue. And what should I need to do is to as the response. I have response. I have response. Okay. Ah, nice. What the? It's pretty much readable. Let's evaluate this. And I think later on, maybe beginning of next week, I try to put it in some kind of more readable format. Now I will just I have the CSV file, not that one, not that one, but that one. Yes, with the word counts and that kind of things. I will make a better version out of it, but now I will just make it visible in a Google Sheets. Yeah, okay, just let's see the classify the sentence as positive, negative, or neutral. I'm very disappointed with the service I received at the restaurant. The answers are pretty okay. I on purpose chosen the test prompt which all the three large language models passed from the previous session's test. So I assume that it's testing the test result would be the same. So the sentimental statement is negative. It expresses dissatisfaction and unhappiness about the personal experience in a specific place, a restaurant. Terms like very disappointed clearly indicate an unfavorable review or feeling towards it, hence conveying negativity. Yeah. Based on the given text material, I am very disappointed with the service I received at the restaurant. Can be considered as a neutral statement. The speakers express their negative experience with the establishment but doesn't express any further emotion or sentiment. Okay, Tiny Llama got it wrong. It is clearly a fail. Let's see if this fail forms in the numbers, forms somehow in the numbers. The given sentence stable LLM response. The given sentence is negative in sentiment. The phrase very disappointed indicates that person who spoke these words is unhappy and dissatisfied with their experience at the restaurant. This sentiment would likely not to be considered positive, and neutral could be a possibility if it were presented without any context to imply the blah 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 blah. Okay, it's a bit verbose. Okay, the word count is based on just that. I think P3 performed the best, and the sentence count Tiny Llama would have, because of the verbosity, average sentence length, which shows us how easy to understand, how easy to read. Average sentence length is the highest with the stable LM. Lexical diversity. Okay, so the lexical diversity measures the variety of words in the text, indicating how diverse the vocabulary is. How diverse. The most diverse in V3, the least diverse was the stable LM. Stop word ratio, I think I understood that the proportion of common words, stop words in the text which doesn't carries any meaning, it's the lowest in the V3, so V3 is best performing in that manner. POS counts, let's keep that on the last. The Flash Kincaid grade, highest one is the V3. The education grade level required to understand the text. Education grade level, so it's the highest. Suggests a lower Flash Kincaid grade level suggests a simpler language. So this is a simpler because of the length of the words, I think, counting that in that measurement. That's how I recall from my previous searching. Flash reading keys is the easiest to read. That one, for some reason, it's easy to read. That's also correct, because it's lacking the negative, not lacking the complicated words. Sentiment polarity indicates the positivity or negativity of the text. It's -1 to 1 scale. It's clearly negative. I mean, not the sentiment analysis of the prompt, but the sentiment analysis of the response. So it's negative, it's more like negative in that way, and that's the least. It's nearly neutral. Sentiment subjectivity, if it's subjective or objective, it's in the neutral state. It's objective in that way, and it's more, that's the most objective one according to that metric. Content word ratio, yeah, what are the words it really carries the content. Highest ratio, I think the best. Yes, and it's the best with that, I would say so. Transition word ratio is the highest with the longest text. I assume that because of this however word, that's the reason. The repetition rate, surprisingly the lowest with this, even if it's the longest one, so it's one in that metric. Okay, yeah, and then the POS counts. POS counts. I think it just used that POS counts is a frequency distribution of the part of each text found in a given text. Each tuple in the list represents POS text number. Yes, so it's just a frequency distribution. But even this frequency distribution of the different words suggests us, for example, in the content word ratio, it's counted based on these numbers, because yeah, I told you before. it's why you're not told but read. Okay, so we have that. I think it works quite good. I think I need to set my mind in a different way or different mode to get this information in the place and evaluate the actual response. I will do broader interpretation of these metrics with all the test prompts with all three models. I will get some fancy output, not really fancy, but fancier than this. Okay, so I think it's a stepping stone to learning tools instead of just prompting. Learning tools how to understand or have a deeper understanding of the large language model and the natural language processing itself. So that's the reason why I would like to show you and show me, show for myself what can be done and how it can be interpreted, how these metrics can be interpreted in the large language model testing. But yeah, there's several tools. That's a lot of tools available. Two tools came in front of my eyes pretty frequently. What one is the DeepEval, which is a Python library made by Confident AI, and one is the Evidently, which has a large language model evaluation Python library, LLM evaluation. Yes. So these two tools, the DeepEval and the Evidently AI, both tools, as far as I just scroll down and getting a bigger picture, with the DeepEval and the Evidently would consist many metrics, textual statistical metrics, and have different kind of broader and bit fancier metrics than just pure statistical. Both tools has the functionality of using large language models as a judge, which means that if we get a prompt and get a response and we set a context to the tool, to the specific prompt, it will use language models from Hugging Face or use OpenAI API to interact with ChatGPT to directly ask that if it's a sentiment analysis or more broader toxicity measurement or that kind of things. So in the following two sessions, we will, let's say will be a deep dive, but it will be a shallow deep dive, of course, for the sake of the 1.5 or 2 hours of this live session and the edited video. But it would be really interesting to get to know both of these tools. So that's for the future. But for now, the NLTK Python library is I found it really useful and really interesting. And as I dig the information out in this week about the NLTK, it really set myself, I've set myself to the more technical situation, a more technical position, at least I felt like it, and to know the large language models better, and a bit I have put into a position of not a linguist but a developer or any person who would like to understand better the natural language processing. So it was a really nice feeling, and I think if I would like to deepen my knowledge in natural language processing and testing large language models, I feel I really feel the need to use this NLTK and maybe the other tools as well. I think we are getting to an end for this session now. So the usual stuff, guys. So please leave a comment underneath the YouTube video, which will be out mid of next week. I would be really glad that if you would join to the live session, because I think it can be fun, or you can just really see as a Friday night session of yours. And don't forget to follow me on LinkedIn and leave some comments in the post if you liked. Push to the like button in YouTube, in LinkedIn, and Twitter. Whole atmosphere of these social media platforms could be really toxic, and some openness and honest learning journey sharing is really a good thing to have, and putting away all the perfect Instagram pictures and perfect one-click deployments in another more realistic perspective. Yeah, so that was all, guys, for today, and let's join the next live session in next week. That was all. Take care, guys. Bye bye.